right, so 2.6, proving statements about angles. So obviously you probably noticed through the PowerPoint, but also when you did your theorem and postulate book, there were a lot of theorems and postulates that were in this section. Obviously you have them in your book, but you need to be familiar with them so you're not sitting there trying to like figure out, you know, what do I need or whatever to help you. If you kind of are familiar with them, it'll make your life a lot easier. Obviously, as you do your problems and your homework, it's going to probably take you a little bit longer, but hopefully by then you'll kind of be used to them so that when you get to the test and the quiz, that you'll like be ready for that. So first of all, we are going to look at 4 through 9 tells us that angle 1 and 3 are a linear pair. Angle 1 and angle 4 are a linear pair. And then angle 1 and angle 2 are vertical angles. Is this statement true? So number 4, angle 1 is congruent to angle 3. Is that true based on the information that you're given right here?
Yes.
Why?
So, linear pair.
Does linear pair mean that they're congruent?
Yes.
Vertical angles are congruent, but linear pairs, they could be, but they don't have to be. So we don't have enough information to know. So this would be false. Or I guess it's saying, is it true? So no, it is not true. 8. Angle 3 is congruent to angle 4. Is this true? Okay, why?
Because they're not vertical angles.
Well, they're not vertical angles, but that doesn't mean that they're not congruent. So, Abby, why'd you say yes?
Because if you knew that 1 and 2 are vertical angles, so like 3 and 4, 3 and 4 would have to be 2.
Probably, but not necessarily. But I know that 1 and 3 is a linear pair and 1 and 4 is a linear pair. So if that's the case, they both have 1 in common, right? So that means that 3 and 4 would have to be the same. So this one would be yes. All right, this one we are proving theorem 2.2. So we're given that angle A is congruent to angle B, and we're going to prove that angle B is congruent to angle A. And they show us angle A and angle B.
Are we making this statement in reason term? Okay.
Now, in this case, they've given us part of the proof and we're filling in the blanks. So I'm going to write in black what they gave us and then we'll fill in the other part. So they tell us angle A is congruent to angle B. I'm going to work down on the statements. 2, they leave blank. We have to fill that one in. 3, the measure of angle B is equal to the measure of angle A. And then 4, angle B is congruent to angle A. Reasons. Number 1, we have to fill it in. 2 is the definition of congruent angles. 3 and 4 we have to fill in ourselves. Alright, so let's just work our way down. So the first thing is that angle A is congruent to angle B. What's the reason for that? Given. Alright, over here they tell me that the reason's going to be definition of congruent angles. So what's going to need to go in this box then, or in this blank?
Measure A equals measure B.
Yep. Measure of angle A is equal to the measure of angle B. Then they go, measure of angle B is equal to the measure of angle A. What allows me to do that?
Reflexive property, not reflexive, the symmetric.
Yep, symmetric property. And then lastly, angle B is congruent to angle A. That's the reason for this one. What? Nope, that's what we're trying to prove. Yep,
can be multiple
definition of congruent angles. So your first step, probably 99% of the time, should be whatever the given is that you write that down. Your final step will always be what you're trying to show, exactly as it is. So I know that, obviously in this case, I knew that that was the last step. But whenever you're done, you should make sure, okay, what did it tell me I was trying to prove, so that way you know what you're trying to get to, okay? Okay. The next one gives us kind of a interesting picture here. So I'm gonna like draw the picture over here on the side, and then we'll go through the statements. Or well, here, let me do this first. They tell us that the measure of angle EHC is equal to the measure of angle DHB is equal to the measure of angle AHB, and this is 90 degrees. So that tells me that all three of those angles are 90 degrees. All right, and these are going counterclockwise, the letters from A through G on all of these. So A, B, C, D, E, F, G, and then the center point is H. And my angles, this is 1, 3, 4, 5, 6, and 7. And I don't really know why they skipped 2. But I'm assuming 2 was supposed to be there, but they didn't put 2 there. So you just don't need it. All right, so what I would do when I have a problem like this, and I know I'm going to be like using it to answer questions, is I'd probably go in and try to fill in this information on my graph, because it probably is going to help me. So EHC, that is this right here, I'm told is 90 degrees. That means that this is a right angle. So I'm going to put my little right angle box here so that I know that that's 90 degrees. DHB would be this one down here. Well, I also know that's a right angle, so I'm going to put a box there. And AHB, that one's probably the most obvious that it's a right angle, but I'm going to put a box there. So they're kind of overlapping. It obviously makes it a little bit chaotic, but that will help me as I go to solve my problems. If I put all my known information on my pictures, it's going to help you a lot, especially if you're a visual person like me. So problem 12. If the measure of angle 7 is equal to 28 degrees, then the measure of angle 3 is equal to blank. So angle 7 is 28 degrees. What does that mean about angle 3 down here?
It's 20 degrees.
Yep, and why? What are these two angles? Yep, they're vertical angles. Now, you don't have to write the y. I'm just doing this so that you can see. Turn this thing off, so stop doing that. Okay. 14. If the measure of angle 3 is equal to 34 degrees, then the measure of angle 5 is equal to blank. So 3 is 34 degrees, and I'm trying to find 5. Any idea what I might need to do here?
Subtract 34 from 90. I think.
Okay, why are you doing that?
Because the lines of 3 and 5 make 90 degrees.
4 and 5 make 90, and 3 and 4 make 90, but 3 to 5 make more than 90.
I'm confused which line is which.
The blue 4 and 5 is a right angle, and then down here 3 and 4 is a right angle. What do I know about 3, 4, and 5?
They're all right angles.
Well, 4 and 5 is a right angle, and 3 and 4 is a right angle. So what's the common thing there?
4.
Angle 4 is in both. So what does that mean about 3 and 5?
They're the same.
They have to be the same because 4 is in both of them. That means that 3 and 5, if they're in fact 90 degrees, which they tell us that they are, 3 and 5 have to be the same. So that means that this is also 34 degrees. The measure of angles, or not measure, angle 3 has to be congruent to angle 5 because of given info. Okay, again, you don't have to write that part. That's just if you want to know why. One more of these ones. 16. If the measure of angle 7 is equal to 31 degrees, then the measure of angle 6 is equal to blank. Any ideas?
Seven and 6 seem to be a right angle.
So we're not told that. So unless we're specifically told that, we can't assume because the pictures aren't always proportionate.
Okay.
What do I know about 4 through 7?
It's supplementary.
They're supplementary, right? Well, what do I know about 4 and 5?
They're right angles.
Right.
They're a right angle. So I know that 4 and 5 add up to 90 degrees. I know that angle 7 is 31 degrees. So what might I do to solve for angle 6? Yep. So we're going to do 180. Whoa. So that, well, let me do this. The measure of angle 6 is equal to 180 minus 90 from angles 4 and 5. So that was angle 4 and angle 5. And then minus 31, which is angle 7. So that means that that's equal to 59 degrees. So angle 6 is 59 degrees. So now, they do happen to be right angles, but we weren't told that, so we can't assume because my picture might not be perfect.
Deduction of reason.
Do what?
Deduction of reason.
Yeah. So, like, now I know that because I've solved for it, I know that they are right. But I didn't know that technically up front.
I just skipped a step.
Yeah, pretty much. Okay. Couple proofs here. So number 18, it is another fill in the blank proof for you to fill in, and then we'll jump into 26, which is one where you have to do the entire thing. So 18, copy and complete the proof for the congruent complements theorem. So I'm not going to write all the given information right here because it's going to be written in my proof, but I'm ultimately trying to prove that angle 1 is congruent to angle 3. And I have some angles here. So that's roughly what the pictures look like. Obviously not perfect. It's kind of like they took a mirror and like mirrored it over here is what it's supposed to look like. All right, so I'm going to fill in over here. Same thing I did on the one problem earlier with what the statement is, and then we're going to fill in the blanks for the missing pieces. So statement, reason. All right, so the first thing is angle 1 and angle 2 are complements. Angle 3 and angle 4 are complements. And then angle 2 is congruent to angle 4. Now, I didn't write it because I didn't want to have to write it twice, but this would have been something we would have been filling in. This was the given information. So, I'm just going to tell you that right now. Okay, so then now, step 2, they give me a blank and a comma and another blank. So that means there's 2 things being filled in here. The reason that they give for this is the definition of complementary angles. I'm just going to work my way down. All right, so what would go here then if the reason is the definition of complementary angles?
Angle 1 equals angle 2, and angle 3 equals angle 4.
Complementary angles,
Oh,
not
equal by
congruent.
degrees.
Yep, so I'm going to say the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees, and then the measure of angle 3 plus the measure of angle 4 is equal to 90 degrees. So again, if you were doing this on your own, this could be one step or it could be 2 separate steps. They did it all as one. 3, they give it to us. They give everything to us. The measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 4. And that's the transitive property of equality. Or, well, I'm just going to say transitive property. They write of equality on all of these. I'm just shortening them. Okay. 4, they say that the measure of angle 2 is equal to the measure of angle 4. And we have to write the reason for this one. So what would be our reason over here?
The definition of congruent angles.
Yep, definition of congruent angles. Again, they give us the step over here. The measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 2. They want us to write the reason for this one. What would be the reason here? How did I change angle 4 to angle 2? Yep, substitution. All right, 6. The measure of angle 1 is equal to the measure of angle 3. How do I do that? Or how am I allowed to do that?
The transitive property.
Nope. How'd I get from here to here? What did I do to get from 5 to 6?
Oh, subtraction property.
Yep, subtraction property. And the last step, they want us to fill in. They tell us the reason is definition of congruent angles. So what would be my last step?
Angle 1 is equal to angle 3.
Angle 1 congruent to angle 3. All right, 26. This one we have to do the entire proof ourselves. So they give me a given is that angle 5 is congruent to angle 6. They want me to prove that angle 4 is congruent to angle 7. The picture for this, looks something like this. This is 4, it's 5, 6, 7. Now, these ones are kind of nice because you're still getting used to it. They give you kind of the plan for the proof. So they tell you to first show that angle 4 and 5, angle 4 is congruent to angle 5 and angle 6 is congruent to angle 7. Then use transitivity to show that angle 4 is congruent to angle 7. Okay, so the first thing that essentially I would do here with this information, well, one, obviously I got to set up my chart. So you can write this given at the beginning if you want. I'm actually going to use it a little bit farther down, but I'm still going to have a given to start with. When they give us a picture like this, this is classified as given information as well, okay? So what do I know about angle 4 and angle 5, and then also about angle 6 and 7?
They're vertical angles.
Yeah, they're vertical angles. So I would say angle 4 and angle 5 are vertical angles. And then I would also say angle 6 and angle 7 are vertical angles. And again, this is given information. It's in the picture, but that's still classified as given information. Okay, you don't have to write the word picture. I'm just doing it for reference for why that's given. So they tell us in the plan for the proof that they want us to show that 4 is congruent to 5 and 6 is congruent to 7. So probably going to go there next since they're telling me that that's what they want me to do. So angle 4 is congruent to angle 5 and angle 6 is congruent to angle 7. Why is that true? It's actually a theorem, but why do we know that 4 is congruent to 5 and 6 is congruent to 7?
The vertical angles theorem.
Yep, vertical angles theorem. So now at this point, I would go back to my given information and I would put this in. Angle 5 is congruent to angle 6. If you wrote it at the beginning as your step 1 or something like that, that's also totally fine. It's not going to change anything. It's just the sequence of where I'm putting it in the problem. So angle 5 is congruent to angle 6. That's also given. So if that's true, what else has to be true?
Measure of angle 5 equals measure of angle 6.
Yes, but I don't need to do that. I can skip that part. What am I trying to prove?
Measure of angle 4 plus measure of angle 5 equals measure of angle 6 plus measure of angle 7.
Not necessarily. I'm just trying to go right here to what I'm trying to prove. Angle 4 is congruent to angle 7. Why?
Those are vertical.
Well, 4 and 7 aren't vertical angles. How did I go over here? I know that 5 and 6 are congruent, and so thus 4 and 7 are congruent. What makes that true? Starts with a T.
Because 5 is equal to 4 and 6 is equal to 7. They're equal to each other.
Transitive
Transitive
property.
property. Transitive property of angle congruence. And again, in the problem, it gave you a plan for the proof, and it says use transitivity to show that, so that would have been your hint there. All right, one last thing I'm going to briefly show you, and then I'll give you your problems. 28. They give us two angles here like this, or well, not two angles, two lines intersecting each other. They say that this is 3y, this is 4y minus 35, this is 10z plus 45, and this is 3 times 6z plus 7. And they want you to solve them. Well, I know vertical angles are congruent, meaning that their measures have to be equal to each other. So I would say that 3y is equal to 4y minus 35. They just want us to solve for the variable. So subtract 4y, so I get negative y is equal to negative 35, meaning that y is equal to 35. Then I'll do the same thing with the z ones. These are also vertical angles. So 3 times 6z plus 7 is equal to 10z plus 45. Distribute 18z plus 21 equals 10z plus 45. Subtract 10z, so 8z is equal to 45 minus 21 is 24. 24 divided by 8 is 3. So that's your values for your y and z. So that's all those ones are asking you to do. But anyways, just so that you're aware on those ones. All right, problems 5, 7, 9, 11, 15, 17, 23, 25, and 27. All right, we have a quiz on Wednesday on 2.4 to 2.6. So tomorrow you will have quiz review to do. I asked her, she hasn't responded yet. On after the quiz on Wednesday, you'll have test review to get started on for your test that's going to be on Friday, which will be the final like big grade of this quarter. We may have like one more grade or a couple more grades, like homework grades next week, but you're not going to have any more big quiz or test grades. So these last two are really important.